So we're going to start our unit on exponential and logarithmic functions, and today we're going to focus on exponential functions, and on Friday we're going to talk about logs. Okay, so an exponential function is any function that has an x in its power. Okay, so quadratic has a what in its power? A 2. Yeah, a 2. But if you'll notice, if this is exponential, a is going to be your number, and it's to the x. So x is up in its power. That's what makes it exponential. And you have exponential growth and exponential decay. Exponential growth doesn't have anything to do with power. It has to do with what's being raised to the power. So if what's being raised to the power is bigger than 1, then your exponential growth. If you invest money in the stock market, do you want exponential growth? Yes. If you have cells in a petri dish and they divide, is that exponential growth? Yes, because if I have 1, it goes to 2, and 2 and 4 goes to, and 8 goes to. So it's not increasing the same amount every time. That would be linear. So exponential, it increases at a really fast rate. So I start out with my measly little $100, and then it grows and grows. And as you get more money, if you're talking about money, like let's talk about like money in a bank account. Let's say I work all summer and I save $1,000, and I put it in a savings account and it earns interest. Let's say it earns 5% interest. So the first time I earn interest on my $1,000, right? The second time I earn interest, is it just on that $1,000? It's on my $1,000 plus the interest I earned last time. So I'm making money off of money that was never mine. Does that make sense? Okay, decay. If your a, the guy that's being raised to the power, is in between 0 and 1, so a fraction that has to be less than 1, then it's decay. Would you want to invest money in the stock market and have exponential decay? No, that's very, very bad. But please notice, these have asymptotes. Because if I invest $1 million in the stock market and I lose tons of money, is that ever going to go negative? Like, do I ever owe them money? No, I can go down to 0, but I will never owe them. It'll never go negative. So there is a floor. Correct. So technically, if you're losing 1% of what you have, you can technically never go to 0 because it's 1% of what you have. Okay, do you notice that they both have a y-intercept at 1? Can anybody tell me why? Look at the function. Why? No matter what a is, because anything to the 0 power is 1. And who's your power? X. So if x is 0, so anything, a star, to the 0 power is going to be 1. So when x is 0, y will always be 1. I don't care what you're raising to that power. Got me? So this is sort of like home base. Growth and decay both go through that point, and the asymptote is 1 below that point. Now we're going to shift. We're going to go right, left, up, down. We're going to flip. And it's all based on this point right here. So he's very important. And when it's all said and done in your graphing, you have to label that point. Until you shift it. Yes. Okay. So first, tell me if these are growth or decay. Let's just go G and D. So look at number 1. What is it? Growth. Growth. Decay. You do? We're pretty split. Look this way then. So it's growth. And that would be growth. All right, so y'all are right. A negative power, number one, does not make that 2 negative, and nobody said that, so that was really good. It does mean that you move it. Negative exponents, we move, right? Does that sound familiar? Okay, so this becomes 1 over 2 to the x. So now your A is a 1/2, which is smaller than 1, so your decay. So that's the one place they can be tricky. They're going to throw a negative up in that power, and they expect you to know that whatever it was, it is now the opposite. Okay, so let's do a what if, and we're going to draw these in just a second. But let's say I have this. So that's 3 over 2 to the x, which is now growth. It was decay, but because of the negative power, it now becomes growth, because 3 over 2 is bigger than 1. How cool? Okay, so let's draw. Okay, so what's home base? What do they always go through? Yep. So every one of these is going to go through their little home. Where's the asymptote? Always. No, it's not always. It's always one below wherever their home is. So if this is his point, then the asymptote is one below it. But guys, when we start shifting that point, the asymptote is going to go with him. So all these asymptotes are nice and easy. Now growth starts out low, hits that point, and then really goes up. And I know this sounds like really petty, but you need to put arrows on the ends of your graph because these graphs keep going. This one's a growth. So tell me what the difference is between the 2 and the 4, because I don't see any difference between their graphs. It's how quickly it grows. But we're not interested in that. Okay? We don't have to go there. So number 3 is decay. Decay starts high. Start with all your money, and then you lose it all. Hit that point, and then it does not level off. It never becomes horizontal, because remember that asymptote is constantly pulling it towards you, towards itself. And then number 4 is decay. And then the last thing you do, and right now this is a pain in the butt because they're all the same, you have to come in here and label this point. And you'll see why once we start moving it. Oh, Lord. It is. See, I did a good job. Way to pass the test because I did that on purpose. Good job. Making sure you're on your toes. All right, cool. Do you remember? Oh, I don't know, second week of school? Just like it was yesterday, right? Okay, we talked about parent functions. Absolute values, quadratics, cubics, okay, linear. And then we said, if you add or subtract something on the outside of the function, it's up, down, true to the sign. But if you put a plus or minus inside the function, it's right, left, opposite the sign. Remember that? Okay, did you remember handstands and twirls? Okay, so when do we handstand? When you're outside. You can't do handstands in the house. You got to go outside to do your handstand. So a negative on the outside, and I don't see any on this right here. And then when do you twirl? When you have a negative on the inside of the function. Now, our function now is to the x. So when we say inside the function, we're talking about up in that power. Okay, number 5 doesn't have anything else up there with that x except that negative. So instead of thinking of that like a twirl, what would that negative do to the 2/5? Flip it and make it 5 over 2. So now are you growth or decay? You're growth. You go through 0, 1 because you didn't shift it all. Asymptote is 1 below it. Growth. Label your point. Make sure you put the 0 first. So number 6, I see a +1. Where is it? Is he outside the function? Or is he up in the function? He is. He's up in the function. See this -4 over here, way over here on number 8? That's outside the function. Okay, so this +1. Okay, so first of all, are we growth or decay? Okay, and where are we going? Very good. Left 1, because there's a +1 up in the function. Okay, so now where's home? Where do I always start? So here's where I'm starting, and I'm going to shift that point left 1. Where's your asymptote? Can't say 0. You got to say y = 0. Yeah, it's a horizontal line. And we're growth. And then you have to label that point correctly. How's that?
So when the point changes, we don't have to go through the zeros?
You don't go, because once you've shifted that point, you don't live at that point anymore. And if I had an eraser or a pencil that didn't make a big of a mark, I wouldn't still have that point there. Hey, this matches. Number 7, growth or decay? And where are we going? Good. Okay, so start at home base and go right to. Asymptote has not moved. It is still at y = 0. You are decay. Decay starts high. Lose all your money, but don't cross the asymptote. Okay, talk to me about number 8. Decay and down 4. Okay, so start here, and I'm going down 4. 1, 2, 3, 4. All right, ladies and gentlemen, where's your asymptote? One below that one. And I'm decay. Decay starts high. This is not a right turn. Okay, so please don't do that. It's not an L. It is a curve. It's a definite curve. All right, where are we? 0, -3. Why is it not -4? I went down 4. I started at up 1, so be very careful with that. But I will say this, your asymptote, when you shift it up or down, because it starts at 0, if you go down 4, where's your asymptote? It's at -4, at y = -4. Okay, everybody doing okay? More of the same. Here we go. Tell me what we are. Growth, and we are up 2. Okay, so I'm starting here, and I'm going to go up 2. Where's your asymptote? Very good. Y = 2. 1 below it. Okay. And I'm growth. Oh, I missed my point. That's when you just go in there and make it bigger. And what's my point? Okay, now you try number 10. Decay, left 4, down 3. Start at 1, left 4, down 3. Asymptote is 1 below it. Decay. 1, 2, 3. -4, -2. Everybody cool? Okay, try 11 on your own, but then stop. Don't go on to number 12 because he does something different. So just do number 11. I'm at 1, 3. Yeah? Yeah. Okay, number 12. Does that negative on the 4 change it to decay? Well, right. It's 4, still 4 to the x. So we're growth. Oh, hello. We're growth. What does a negative do when you put it in the front? Flips it which way? Like a handstand, right? Okay. When you flip it over its asymptote. Okay? So watch. This is not up, down, right, left. This is just right home, right? Because he has no shifts. Okay? Draw your asymptote. Because if I have to flip it over the asymptote, I need to see where the asymptote is. Now, when you flip it, if your point is 1 above your asymptote, when you flip it, where are you going to be? Exactly. Here's what I don't want you to think. Flipping growth does not make it decay. Like, if I did a handstand, would it change who I am? No, it would just be me upside down. So this is still growth. It's just growth that's getting flipped. Well, I'm artistically challenged. I can't visualize what that looks like. Like I have to see it. So you're going to see me do this. When it's growth, I have to come in here and draw what it would have been so that when I flip it, I can just mirror image that. Y'all see what I'm saying? I can't just draw upside down growth. I'm just not that talented. So I have to dotted line that sucker in so that when I flip it, I know what I'm flipping. Now, when you label your point, which point do you label? Yeah, the new one. So I'm at 0, -1. Okay, so when you handstand, what do you handstand over? The asymptote every time. I don't think we do any that have a shift and a twirl. Now we twirl logs, but I don't think we twirl exponents or exponential functions. So tell me about 13. Down 2. Which way? Left 3. What are we? We are decay. And we are flipped. Technically, we're flipped over the, well, you wouldn't even say x-axis. You would say flipped over the asymptote. So we'll just say flip. Do what? Flip. Flip is good. You could write handstand. Go to college and write handstand. Do that for me. Okay, so I start here. Okay, where am I going? Left 3. Okay, 1, 2, 3. 1, 2. Put my dot. I put my dot there because that helps me know where my asymptote is. Okay, I am decay. Now, I'm not drawing this one solid because this is not my answer. This is just because Ms. Patterson can't visualize. Okay, now I got to flip him. So if he's 1 point above, he's going to flip and become 1 point below. And then I just mirror image that. And now I need to know where I am. 1, 2, 3. Are we good? Talk to me about number 14. I disagree. 1.4 is more than 1. You are absolutely right. But you see it's to the negative x. So that's really 1 over 1.4, which is smaller than 1. So now we're decay. Okay, any shifting? You see plus something outside the function or minus something, or plus or minus something inside the function. There's no shifts. That 3 just makes us decay faster. We're not worried about that, okay? Yes. Mm-hmm. Mm-hmm. So let's see. I live right here. Asymptote is right there. And the only thing I am is decay. That makes us decay at a faster rate. We don't, that's not in our, I mean, we can go into all kinds of detail. That's just, we just don't have to cross that line and go into that. Okay, and then Stephen, you said, how do you see a twirl? Okay, so technically think about this. If this is growth, and I twirl, see how I'm decay now? So the negative that's on the x inside the function, there's your twirl. When you change it from growth to decay, that's your twirl. Okay, so you're going to try 15 all by yourself. How'd I do? Yeah? Everybody cool? Everybody good? Can y'all flip it without drawing it originally? God. In my next life, I want to be able to do that. Okay, done. Are y'all sitting here like anxiously waiting for it to get more difficult? It doesn't. Breathe. It doesn't. Okay, everybody breathe. Everybody exhale. It's okay. All right. Natural base E. Do you remember him from this math 3? Math 2? Math 3. Okay. So E. What is E? Yeah, it's 2.7 and some change. It's just like pi. It's a number. It's a constant, and that's really important to know. That E is not a variable. E is a constant, just like pi. It's 2.7 and some change. Okay, so I need you to make a mental note. 2.7 is bigger than 1. Agree? Okay, store that little fact away for later. Okay? You have an E button in your calculator. Can you grab your calculators? Oh, and look, I have a new calculator on my smartboard. It's really cool. Hold on. Please work. There he is. Yeah. Yeah. Let's nerd it out. Here we go. Okay, I still can't read it though. Where's E? All right, here you go. Everybody see E? He's right here. He's right above your ln. So we are, will it not? Okay. We're going to do e to the negative 2, which is literally going to take 2.7 and all those decimals. It's going to raise it to the second power, and then it's going to do 1 over that number. It's going to do it for us. So we're going to go e to the negative 2. Let's go 3 decimal places, shall we? So let's make sure we can round. 135, 0.135. What's e to the negative 1 going to do? 1 over that 2.70 number. Yeah. So, no, you just put e to the negative 1. 0.368. Good. Okay. E to the 1. 2.718. And e to the third. Yeah, 20.086. Everybody happy? Is e a variable? No, never changes. 2.7 and some change. It's a constant. Okay. So now you're going to graph it, because isn't e to the x an exponential function? Why? Because it has an x in its power. Okay. So his graph looks just like this. There's his home. It still goes through 1 or 0, 1. Why? E to the 0 is 1. Okay, so guys, you're going to shift it. You're going to flip it. You're going to growth and decay it just like you've always done. Always for the last 45 minutes. This is what you're going to do. Okay, so tell me for number 20, are you growth or decay? How do you know? E is bigger than 1. E is 2.7, so we are growth. All right, now shift it. Okay, so we start, and then we go left 2, down 4. Could I go down 4 and then left 2? Could you? Just asking. Yes. Yes, you could have. You'll end up at the same place. It's not like a slope. You're just doing 2 transformations. Where's his asymptote? And we're growth. No. I mean, no, but no. Where are we? Negative 2, negative 3. You don't need to label as asymptote, no, but maybe down the road if I said, hey, what's his asymptote, you wouldn't dare say negative 4, right? Just checking. All right, 21, growth or decay? Huh. See, y'all see negatives and you get trigger happy. He's growth. What's the plus 2? Up 2, because that's outside the function. And what's the negative in the front? Not up in the function. He's a flip. All right, go. You do it. Nope. Nope. There we go. Ironic that it ends back up there, isn't it? When you do this, please make sure that this guy that you're drawing, the dotted line, is a dotted line. Please don't draw 2 solid lines, because then you're I don't know which one is your actual graph. Okay, the dotted line is just to help me visualize it. Okay, 22, what is he? Moi. It's 1 over 2 and some change, which is going to be decay. He's not shifted at all or flipped. He is just decay. Guys, we have 2 problems left and I'm done. We might set a record. Oh, forgot about these 2. I was talking about those 2. All right, we got 4 left. Sorry. Then I'm done. Okay, tell you what, you try these 2. How to do? Everybody good? Any questions? Anything we need to talk about? Hey, guess what? Now we have 2 problems left. Remember these? What is it that your sweet little Math 3 teacher taught you? Yeah, Roy. Y'all remember Roy? Roy needs new tires. When it's an off basketball season for the Tar Heels, kids usually say it's Roy needs new Tar Heels. I think we're going to be pretty good. Now, the football team needs some new Tar Heels, but okay. Yeah, it's bad. All right, here we go. This is when you're compounded. Compounded means you get your interest. Okay? This, you use Roy needs new tires. Does everybody see why it's Roy needs new tires? This part you're on your own. Sorry. What's P stand for? No. Your Miss Cheek. Your principal. Your principal. What's R? Your interest rate. Yep, make sure you turn it into a decimal. N is the number of times per year it's compounded. So let's say your bank compounds annually. That means once a year you get interest. Kind of sucks, doesn't it? Biannually. Quarterly. Okay. Monthly. There you go. Okay, now, there are places that compound continuously. Doesn't that sound like something we would want? I want my interest all the time. Like, keep hitting that total button. I want all my interest all the time. This is compounding your interest continuously. That's PERT, P-E to the R-T. PERT used to be a very popular shampoo. I think it's still out there. Is it a green bottle? Okay. Continuously. So here's how I remember it. I'm continuously washing my hair. That's how I learned it in high school, and that's just sort of what stuck with me. So PERT is continuously, but if you don't know that PERT's a shampoo, that's not going to help you at all. So we're going to compare. Now, if I had $12,000 and a bank, number one, that's a good interest rate. Yeah, I mean, that's a heck of an interest rate. Don't you think that we would earn so much more money if we were compounded continuously than if we were compounded quarterly? Let's do it and see. So A stands for your amount, or like your total. So P is your principal, so what are you starting with? 12 grand. 1 plus, and that 1 right there, guys, that's because you don't just want to know your interest, you want to know your total. So it takes your 12,000 and adds it to your interest rate. So 1 plus, all right, Roy, what's my percent? 0.09. 9%, scoot your decimal twice. 0.09. Why do you scoot your decimal twice, by the way? Yeah, it's 100. It's out of 100%. How many zeros does it have? Does 100 have? That's why you scoot it 2 places. Over. Now, what does N stand for? The number of times per year. So for to the. There's your 4 again. So you got 4s back to back there. Times how long are we leaving it in there? Okay, now, the really funny part is watching y'all try to plug this in. So I'm not going to say anything. I want y'all to plug it in, and let's see how many different answers we get. Now, y'all may surprise me. I hope you do. But this is always really funny to me because students have a hard time typing this in. The newer operating systems on the calculator helps. Okay, here I go. And some people like to type it in parts. I don't recommend.
You forgot it's 0.
Oh, it's 12,000. Yeah. Insert. Yeah, that's a big difference in it. 094 divided by 4. Okay, to the. Now, oh, nope. When y'all hit your to the button, does it pop you up in the power like this does? See, that's the new operating system, and that has saved tremendous amounts of issues because a lot of times it didn't, Adam. A lot of times it doesn't. And so when you do your to the and you just type in 4 times 5, what's your calculator going to do? No. I wanted to do 4 times 5. It's going to do it to the 4th, then take all of that answer and multiply it by 5. But I want the 4 and the 5 both up in my to the, right? Well, I don't have to because mine jacks it up there. Like I can see that my 4 and my 5 are both up there. Now, make sure it makes sense. How much money did I start with? $12,000, 9% interest. That's not bad. 5 years. What am I making? $6,000 and some change? That's not bad. Now make this look like money. Does the bank round to the nearest dollar? Then probably not. They have to. It's your money. You don't round. Go to the penny. Okay, so don't ever round to the nearest dollar. So $18,726 and if that third decimal tells you that you get 1 more penny, then you round up to 12 cents. 5 or higher, round up. 4 below, stay. There's a rhyme for that. Something stay. There's a yeah, no. There is. There's a rhyme for that. Okay, so now compounded continuously. PE to the RT. So P is your principal. Who's E? E is E. To the, who's your R? 0.09. And how long are we going? So do you see how there's no N? Okay, type this in. Look at all that extra money we got from compounding continuously. Isn't that kind of anticlimactic? Yeah. Over the course of 5 years, at a really good interest rate, too. How much money are we talking? $18,819.75. Absolutely, get that extra penny. Okay, is this sort of like a letdown? Yeah. Don't you think that's a letdown? Who is this going to make a big difference to? Like for me, with my cute little $12,000, I wish. My cute little $12,000, it doesn't make a bit of difference, and that's at a great interest rate for 5 years. Who does this make a big difference for? Corporations, millionaires. When they are investing millions and trillions of dollars there's no way they get a 9% interest rate for that amount of money. And they're going to leave it in there for the duration of their company. That's their nest egg. I mean, have you ever heard somebody say, yeah, I'm living off my interest? Yeah. I'm just living off. I haven't touched my principal. What does that mean? I haven't touched how much I invested. I'm just living off my interest. I'm living off of the bank paying me money so that they can hold my money. Why do they need to hold? Why do they care if they hold my money? Why are they paying me money?
Because they let other people borrow.
Yes, when I give them my $12 bazillion and you go to the bank because you've just bought a car and you need a loan, they're giving you some of my money. They can't give you money that they don't have. So is there a shelf in the bank, in the vault that says Miss Patterson and has my $12 bazillion sitting on the shelf? No, it all goes into one big pot. And you see banks that are FDIC, federal something insurance, there's something, Federal Department of Insurance. Insurance Corporation. I bet that's it. Yeah. Anyway, so what that says is if that bank happens to go bankrupt and I go to the bank or to a withdrawal and they say, I'm sorry, we don't have your money. We've gone bankrupt. That the government insures that bank. So if I have documentation of how much money they have of mine, the government will give me my money. So, yes, up to $250,000. So if you, that little loophole. So if you ever go bank shopping, do you want to make sure that they have that little FDIC on it? And most well-known banks that you see through Walnut Cove or King or Winston are going to be FDIC insured. It's when you get that random piece of mail to you with, hey, we'll give you an interest-free credit card for 6 months, and they tempt you to open up a new credit card, but then after 6 months, what happens to that interest rate? Oh, it goes like 37%. Yeah, it's ridiculous. Ridiculous. And if it's a little no-name place, they don't necessarily have to be insured. So, just be careful. Okay, do we feel good with these two formulas? Do you already have them memorized? Roy? And good old Pert? And how often do you wash your hair? Continuously, absolutely. Okay, excellent job, guys.